when we do some research regarding the conventional plastic packaging. Numerous approaches for creating safe and dependable biodegradable food packaging. Then, alginate and pectin is proving to be useful in the food packaging industry. Besides, benzoic, sorbic, and lactic acid are among the most weak organic acid antimicrobials. Last but not least, zinc oxide nanoparticles improve antioxidant and antimicrobial activity in food packaging.
Plastic waste is piling up in the world's landfills, sewer systems, and in the ocean.
Food waste. Hundreds of tons of it here at the largest food collection site in London.
It's to do with the infrastructure in our homes, it's to do with the skills and the knowledge that we have, it's to do with how time poor we are.
Including a multi-state outbreak of E. coli in 2018, in which 210 people got sick, of whom 96 were hospitalized, and 5 died.
The soil burial assay method indicates, as evidenced by the biodegradation graphs, that nanotriacid films exhibit a higher biodegradation rate compared to both the control film and the films developed in prior research. Contributes to this film easily degrades and eco-friendly. In this study, the nanotriacid films exhibited a greater thickness compared to the control film. Additionally, the moisture content of the nanotriacid films was found to be higher, which contributes to enhanced food moisture retention and preservation of antioxidant properties. Furthermore, there was no statistically significant difference observed in tensile strength and elongation at break between the nanotriacid films and the control film, indicating that the films possess a comparable resistance to breakage. Nanotriacid films have good water-resistant characteristics, where they have lower water permeability compared to control films. When analyzed by using an FTIR machine, all nanoparticles and organic acids have been incorporated in the films. When tested with foodborne bacteria on Agar diffusion assay, all the bacteria tested were effectively killed. And when tested in Hohenstein challenge test, bacteria killed percentage have a good result between 21.45% and 75.80%. Then, the film was wrapping foods such as rice and tested the bacterial growth reduction with the result achieving a 90.58% reduction on day 5 and a minimum of 55.03% on day 1. Besides, this film was proven to be a natural fertilizer and pesticide based on observation from day 1 to day 5 and R1 to R5. Lastly, this film can be remelted and reused into new films. It can also be recycled into creative art products.
Firstly, this film uses 3 types of synergistic acid that have never been used in previous biopolymer packaging and act as an antimicrobial agents. Next, this film able to kill bacteria and mold in terms of increasing food long-lasting and durables. Then nanotriacid films is sustainable and easily decomposable compared to conventional plastic packaging in reducing environmental pollution. Other than that, this film is able to maintain food's moisture content and freshness. Besides, this film can act as natural fertilizer to support plant growth. Nanotriacid films also acts as a natural organic pesticide in the agricultural area to remove pests from disturbing plant environment. Nanotriacid films also reusable, where it can be remelted to produce new film. Last but not least, this film can be recyclable into new products such as Purpolol or Bunga in Mele, wedding ceremony. The materials use meet Food Drug Administration safety standards and are generally recognized as safe. This contributes to nanotriacid films being food grade by biopolymer packaging, with a low production cost compared to conventional plastic. It's financially viable with proof for profit where total target sales are still in the market range. Technically, the film incorporates organic and natural sources where it can be reproducible. The necessary production equipment is also readily available, confirming that the film is both safe and feasible for large-scale production.